Okay, so in this video, we're going to go through sample question 107 from the Society of Actuaries ExamP list of sample questions. The question reads, let X denote the size of a surgical claim and let Y denote the size of an associated hospital claim. An actuary is using a model in which, and then gives the following information, some expected values, the variance of X plus Y. Let C1 equal X plus Y denote the size of the combined claims before the application of a 20% surcharge on the hospital portion of the claim. Let C2 denote the size of the combined claims after the application of that surcharge. Calculate the covariance of C1, C2. Okay, so first we're going to need to know what C1, C2 actually are. We're going to want to write those down. It gives us that C1 is X plus Y. C2 is the size of the combined claims after that 20% surcharge on the hospital portion. Since Y is the hospital portion, we're going to increase that by 20%. And that's just multiplying it by 1.2 there. So now we want the covariance of C1, C2. And I'm going to just do some replacements. This is the same thing as the covariance of X plus Y, X plus 1.2Y. Now, a couple of routes I can go down, right? The version you're probably familiar with and what you might instinctually go to is, okay, this should be equal to the expected value of this times this minus the expected value of the first thing times the expected value of the second thing, right? That's kind of how a lot of covariance problems will go. However, I see that covariance is bilinear, so we can expand the brackets the same way that you would almost FOIL. Okay, you'll see what I mean in just a second. So this is going to be equal to the covariance of X times X, right? Except we're not multiplying, it's X comma X, plus X comma, covariance of X comma, 1.2Y, plus covariance of Y comma X, plus covariance of Y comma 1.2Y. All right. Now that we've done that, let's clean this up a little, right? There's a couple more things that we can kind of convert and find equivalent things of. So you should know that the covariance of something with itself, like a random variable with itself, is just the variance of that thing. So the covariance of X comma X is equal to the variance of X. Simple enough. I can bring this 1.2 to the front and make this 1.2 covariance of X comma Y. And I'm going to switch the order of this, right? It's not necessarily wrong, but it'll be easier to work with if I rewrite this as covariance of X comma Y. And here, same rule with that 1.2. I'll just add 1.2 covariance of Y comma Y. And hopefully you can see there's some more stuff we can kind of simplify, combine. This variance of X is fine as is. 1.2 covariance of XY plus covariance of XY is 2.2 covariance XY. Right? We truly are back in a 7th grade class, combining like terms, foiling. 2.2 covariance X comma Y plus 1.2. Same rule we used up here. Covariance of YY is just the variance of Y. Okay? And this is pretty good. They give us the variance of, oh no, they don't. Actually, they only give us expected values. So we actually need to calculate the variance of X, variance of Y, as well as the covariance of XY. Okay. So let's get into this. So variance of X, pretty simple. That's equal to the second moment minus the first moment squared. And since it gives us those values, expected value of X squared is 27.4 minus 5 squared. So that's 27.4 minus 25, 2.4. variance of y is equal to, expected value of y squared, 51.4 minus 7 squared, which is 49. And that gives us also 2.4. Cool. Okay. Now we need to find covariance of xy. And this would involve needing the expected value of xy, which we don't have. But they do give us this. The variance of x plus y is equal to 8. A formula that you should be familiar with is the following. The variance of x plus y is equal to the variance of x plus the variance of y plus 2 times the covariance of x comma y, which is, this is the thing we're looking for. And we know these three things, so let's just substitute. We're given that this is 8. We have already found that this is 2.4. We've already found that this is 2.4. And we're looking for what this is, so that's our unknown, to covariance x comma y. This will become 4.8. That shouldn't have taken me as long as it did. 4.8 plus 2 covariance of x comma y, and just to make sure I'm not doing any silly mathematical error, 8 minus 4.8 is 3.2, and I take the 3.2 and divide it by 2. So 1.6 is equal to the covariance of x comma y. Simple enough. Now we have everything we need to actually do this calculation, except the r right there. The variance of x was 2.4, and then 2.2 multiplied by the covariance of xy, which we found to be 1.6, plus 1.2 times the variance of y, which we found to be 2.4. Now all of this goes into your calculator. 2.4 plus 2.2, 1.6 plus 1.2, 2.4. And we get a value of 8.8. And that very cleanly matches up with answer choice A. All right, so let's do a quick run through of this problem. Overall, it was fairly simple. We need to calculate a covariance. The hardest part would have probably been that initial setup here, right? Knowing that you're able to expand these parentheses in this way, right? Once you know you're able to do that, then this just becomes, okay, let's find the variance. Let's apply some rules you might have seen on a formula sheet, right? Know a formula sheet inside and out, and then substitute, right, after finding said values. That should be pretty much it. If you have any questions, throw it down in the comments. I will answer to the best of my abilities. If this video helped you out, hit the like button, subscribe. That very much helps me out. And if you want to see more worked out problems like this, I have a playlist. Check it out. But other than that, thank you for watching. Hope this helps.